All right. Well, excellent. Thank you for being here today. And before we start with the lesson today, we had kind of a hypothesis to test from the previous lesson. Okay. Was it Sabrina? I think that the Sabrina was that. Yes, yeah, I think that Sabrina was that she put the question of the types of tides, okay, and where do they occur? All right. So let's see. Let me go to this article here. Now let's open in a new tab, and we go to Lunar Tides. So, what do you remember? What was the question, and what was the hypothesis to test? Okay. All right. Let's see. Well, let me close that mic. Sometimes if you have the speaker going, then it kind of does feedback onto everyone else's. Okay, so we're going to turn that off. But if you remember what was the question that Sabrina brought about the tides and the hypothesis that we were going to test, you can bring that up. All right, I think that it was here on our. I put it into the assignments. Okay, let's see the modules. Let's say here for the lesson, it would be on this one. Hello. All right, no problem. Okay, so the question here was this. Sabrina stated the following hypothesis. She says, diurnal tides, 2 high tides per day, happen close to the equator. Semi-diurnal tides, 4 high tides per day, happen at the higher latitudes closer to the poles. And mixed tides, 4 high tides, but every other high tide is not very high, happen at the mid-latitudes. So the issue, this was the hypothesis, that the type of tides was related to the latitude. Okay. I'll answer that, Spencer, afterwards. Okay. So the question was whether the type of tides depends on the latitude. And the issue was, so if we have here a graph of different latitudes, of different tides, so we have, this is the diurnal tide, so where you have in a period of one day, you have just 2 tides, or the semi-diurnal tides, or the mixed tides, where you have just more up and down, okay, and the lows and the highs are not of equal range, all right? And so Sabrina was asking, do these tides, the diurnal ones, happen close to the equator? Do the semi-diurnal happen in the mid-latitudes, and then the mixed ones in the higher latitudes? Okay, it's not connected. So I wouldn't say that you were wrong, okay, Sabrina. This is a case. This is really how science works, okay? You make a question and you try to make a prediction, all right? So it's not that it's wrong. It's actually very good to ask the question. Do you know who else was, if you wish, wrong about the tides? Galileo. Okay, so Galileo Galilei, all right, that is Everton, okay, All right, I don't know that one. Okay, so Galileo, okay, he wrote in a book, all right, in a book about the Copernican model. Okay, oh, everyone. So everyone was wrong about the tides. Yeah, until recently, everyone was wrong about the tides. But Galileo, he was a very famous astronomer. He was right in a lot of things. But he hypothesized that the tides were the tides were because of the rotation of the Earth. Okay, and he wrote that in a book that got published and everything. All right, and so he basically said because the Earth rotates. Remember, in the Ptolemaic model, the geocentric model, the Earth didn't move, didn't rotate at all. Everything else rotated around the Earth. And so Galileo said that the tides were because the Earth moves, and it was the rotation of the Earth that caused the tides. Okay, so you're right, Mark. It is because of the gravity of the moon. Now we know that. Okay, but what I'm trying to yeah, it was very interesting, and the problem is that everyone could see the tides happening, but they didn't know why they were happening. All right, so imagine in Greek mythology, they even thought the gods were in charge of the tides and everything. So the reason why I'm pointing that out is because that is exactly how science works. We make hypotheses and then we test the hypothesis through observation and looking at things. Okay, so what have you found about the tides? So it is because of the gravity of the moon. We discussed that in the class also. But what makes it so some places have a diurnal tide, other places have a semi-diurnal tide, or other places have a mixed tide? Okay. Any ideas? Were you able to look that up? Okay, let me see if I have this picture here. Places closer and farther from the moon. That is also a good hypothesis. Okay, so the fact of the matter is that for what I've read, so what I did during this past week is I have in my library the book of Bowditch, the American Practical Navigator. Okay, so remember Nathaniel Bowditch? Have you read his book? Okay, so let's see what I think it might have to do with the temperature of the ocean currents, possibly because of greater exposure to ocean front. It's really quite interesting and complex. Yes, it is very interesting and very complex, really. So, what I have read, were we supposed to read the book? The book, yes, not the Carry On, Mr. Bowditch. Okay. Yeah, Carry On, Mr. Bowditch is a fabulous book. Okay, so you really, yeah, it's really really good book. Okay, and so at least you have to read that one. So my wife gave me for my Father's Day present last year the book that Bowditch wrote. Okay, but it's the current edition of the book. It's huge, so it's about this thick and full size. It weighs about 5 pounds, the book itself. And so one of the chapters of the book is on the tides and tidal currents. Okay, and so there are several things really that happen that influence the tides. So it is really an interaction between many, many things. Okay, so this is your learning. So I don't have really a lot of, that was the coolest Father's Day gift really that I got. Okay. So I'm not very concerned about due dates on when you need to do things. This is your education. Oh, am I yelling? Am I going too loud? Sorry. This is a new microphone that I have, so I cannot hear myself. Oh, okay. All right. All right. Am I okay in the volume? So this is a new microphone that I have, and I cannot see my levels. Okay. So, oh no, it seems that it's all right. All right. So the thing is that, okay, the thing is that Bowditch wrote this book, The American Practical Navigator, and one of the chapters here is about the tides and tidal currents. So I read this chapter during this week, and it's very, very fascinating. It explains why is it that the moon, even though it is smaller than the sun, it has much more influence on the tides than the sun does. And the reason is because of this formula. Okay, so this formula here that you see on the screen describes the force differential of the moon and the force differential of the sun. All right, and it is very similar. The formula is very similar to the formula of gravitational pull. Okay. But the difference is that, I don't know if you remember, in the gravitational formula, the distance was square. Here, the distance is cube, all right, in this formula, because it's the force differential. So it actually has one more time that the distance is multiplied here. And so what it makes it is that the distance between the Earth and the Sun is very, very large compared to the Moon and the Earth and the Moon. The Sun is very large compared to the Earth and the Moon. And so when you cube the distances, it makes that the Moon has much larger influence on the tides than the Sun. Okay, so the Sun has like 46% the influence of the of the moon. All right. So another thing that I learned is here in this chapter is that the tides are not only affected by the sun and the moon, but also they are affected by let me go to this chart here. They are affected by the depth of the ocean. It's affected by the coastline, the continental shelf, okay? And so there are many different things that affect how the tides behave, all right? But it's not related so much for the latitude and longitude, okay? It's not related to the longitude, because the moon actually also has a tilted orbit with respect to the plane of the ecliptic. So the moon is not always on the equator. Rarely actually is on the equator. You know, you have the tilt of the Earth here, and then the moon is orbiting this way, okay, around the Earth. So it crosses the equator twice a day, okay, but it is really interesting, okay, all the combinations of the movements of that. In this chart here we have, all right, the tides for a whole month. Okay, so this is a tides table for a whole month, where you have different places: New York, Port Adelaide. Where is Port Adelaide? Find out where Port Adelaide is. I think that is in Australia. Seattle, Los Angeles, Honolulu, and Peihai. So Peihai is in China. All right. So, but see the differences in the tides in the different places. So what type of tides do we see in New York? All right, remember the three types, okay? The three types of tides: diurnal, semi-diurnal, and mixed. So what type of tides do we have here in New York? So each bar represents one day, okay? So here in New York, we see semi-diurnal, all right? Okay. All right, semi-diurnal, and you see that the range, semi means half, excellent. Okay, so you see that every half day you see one high low. Okay, that is really how it goes. Let's see this comment by Annika. Okay, the tides have to do with the shoreline too. If there were no continents, it would all be the same. In the Atlantic, it is slightly calmer, therefore it has a diurnal tide. The Pacific is bigger and more mobile, so the tides are more irregular and high. It doesn't really have much to do with the latitude. I think it really depends on the size of the body of water. Excellent. Okay. So it really depends on the size of the body of water. It also depends on the coastline, okay? So how the coast is, you know, the shape of the coast. All right, yeah, so Port Adelaide is in Australia. Excellent, thank you very much. So here we have New York, like Annika was saying, in the Atlantic, okay, is smaller, but, you know, you see semi-diurnal tides, and the only thing that you see difference is the range here of the tides. All right, what is this? Okay, this means that it's new moon. Okay, so remember that when the moon is aligned with the sun, you have in this case, new moon would be sun, moon, earth. You have a spring tide, so springs is a larger tide. And then you also have the larger tides with the full moon. Okay. Yeah, the Gulf of Mexico is not open to the bigger tides, it's more sheltered, you know, and so it doesn't have that much bigger tides. Okay. So the spring tides happen at the new moon and the full moon. And then when you have the quarter moons, you have what is called the neap tides. Okay. Okay, neap tides. All right. Which are meaning that they are smaller, where you have that the sun and the moon are not working together. All right. What do we have in Port Adelaide? What do we have in Port Adelaide? Okay, Sabrina, you said that the Gulf of Mexico actually has diurnal tides. Okay, where did you find that out? So we have one map here in this article on the tides. Let's see if we can find it here. Yeah, this is an interesting map that it shows us. Okay. Oh, let me open that one also. Okay. Oh, excellent. The same picture. Good job, Sabrina. Same one. All right. So see, here we have a map of the world where we have the different types of tides and where do they happen around the world. Okay, so red is mixed tides. The yellow is the diurnal tides, like in the Gulf of Mexico. And then the semi-diurnal is the green coastline. So the Pacific coast, okay, here in the North America, has mixed tides, semi-diurnal tides, and mixed tides mostly. All right. In Asia, you have also a lot of mixed tides, semi-diurnal tides in New Zealand and Australia, and some places with diurnal tides. So obviously the diurnal tides are the least common, okay? Yeah, it's mostly semi-diurnal. That is the most common along the coastlines, the semi-diurnal tides. Excellent. Yeah. So see, in this case also, you have that in many cases, the tides change during the month. So like here in Los Angeles, we have that at some times or during the month is semi-diurnal, and then at other times is mixed or diurnal, like in these two cases. You see that? So you have 2 days with diurnal tides. Here you have the pattern really clear, and then you have a pattern of mixed tides, and then a pattern of semi-diurnal tides. Okay. Peihai in China has diurnal tides, and then mix, and then back to diurnal, and see how huge the range is of these tides. Okay, so a very high range. So very interesting phenomena, really. Okay, very interesting phenomena. All right, any questions about tides? Yeah, they probably have amazing tide pools. All right, let's find out where Peihai is, shall we? Okay, I'm curious now. So let's go to Google Earth. Okay, let's open that. I always like to, yeah, I always like to know these places. That is my way of traveling. Okay, so let's go. Pay high. Okay. All right. Okay, let's see. Pay high. Where would it be? Over here. So I don't want sightseeing places or auto dealer places. Okay. Okay, it has to be somewhere around here in this shoreline. Okay, so let's see, what is this? Okay. Sometimes it takes a while to find these places in foreign countries. Okay, I don't know that it's in along Hong Kong. Okay. So let's see if Wikipedia is a little easier to find. Okay. Let's see this one here. I missed it? Oh, the big A thing. Oh, sorry. Let's see. The big A thing. A, Peihai. Well, it says Peihai Enterprise Company, so I don't know if that is. Yeah, that is probably not exactly it. Are just restaurant. Yeah, see, that is the problem. The Peihai, and this is an enterprise company. Okay, so but let's see if this is also Peihai is in here in Taiwan. It could be that it's in Taiwan. Okay, so I don't know. Let's try Wikipedia and see if we can find it a little better, easier. Whoa, hold on. Okay. Pay high. Okay. All right, let's see. Okay. There it is. It seems that it's there, so it seems that it's a whole. No, Beihai. Okay, well, Beihai is a whole city. Let's see if we can go to that. Okay, it's right in there. Okay, well, good places. This is another map that I wanted to show you on the tides. This is a map that shows how large or small the tides are. Okay, so the redder the color, okay, the darker the color, the higher the tide is. And you see that it's very different in different parts of the world. Okay, so you have here in Europe, in the Atlantic coast of Europe, that the tides are huge. By Spain, France, especially there, the Bay of Biscay, the English Channel, all around the British Isles have large tides. Also on the west side of Panama, and in the Gulf of Mexico, in the Caribbean Sea, very little tides, not much as a thing of tides. Okay, all right. I found a picture of it. Oh, excellent. Let's see a picture of Peihai. Okay, Peihai, China. All right. The white lines on this map, let's see, the white lines on this map are not currents. They had kind of a weird name, and I couldn't really figure out what they mean, but I think that they kind of were related to currents, all right, and how the water moves. So the dark lines here, those are the currents that are related to the tides, all right? So the ocean has other larger currents, but the tides that are related to the currents are here in this dark line. So you see that around New Zealand, the tidal current goes counterclockwise, okay? All right, and in other places it goes, clockwise and so on. But I couldn't understand. I read about these white lines, but I really couldn't understand what they were. Okay, to tell you the truth. Let's see the picture there of Peihai, China. All right. So can we zoom out of this? Da-da-da. So I would like to zoom out regional map. Let's see if we can. That is probably the regional map. Okay. So Peihai. All right. So it's in a small peninsula there. Okay. Good deal. Let's see if we can find it now in Google Earth. Now I'm curious. Now I'm just really curious. Okay. It seems that this is here. Okay, let's see if we have. Do we have any? Oh, I wish I could go out. Okay. Anyways. Okay. Oh, you can get out blocks. Yeah, I probably need to do that to get all the things out, especially because we are recording this, so we don't want to get the ads in. All right, so enough of tides. Shall we proceed? So, all right, thank you very much, Sabrina, for bringing that up, and that was a ton of fun to do. Now let's go to the class of today. All right. So today we are going to talk about the moon, the phases of the moon and eclipses, okay, both the solar and lunar eclipses. And I have here the links to the lunar phase article, the lunar eclipse, and the solar article. There's a couple of videos, very short videos that explain this, probably at an elementary level, but it would be very interesting. Okay. The activities that I have are very, very interesting. So yes, thank you, Sabrina, for that. I think that these are going to be interesting activities and assignments. So the first one is to find out when the next lunar and solar eclipses are going to be. Mark them in your calendar and be prepared to observe them. All right. So the lunar phases are easy to observe because you can really observe that all the time. The eclipses are also easy to observe, but they don't happen that often. All right, and so we need to pay attention. So I want you to check to see when are the next ones going to be. Okay. All right. They are actually in the next year. Yeah, next year they are going to be 2, Annika, that's correct. Okay. Then the other activity is for you to do lunar observations for at least a complete lunar month. So about 27 days, 28 days. So, and note the phases of the moon from one night to the next, the position of the moon in the sky at the same hour and so on, what is the altitude of the moon and so on. So basically the idea of this assignment is, in astronomy, you have that astronomers do a lot of things by observation, by actually watching things, looking at the sky, all right? The phases of the moon and the moon is one of the easiest things to observe, all right? So I want you to observe that and make notes until you feel confident you understand how the moon works and how the phases of the moon happen, okay? So here we have a very interesting diagram that explains the phases of the moon. All right, so we have here the sun. Okay, is far, of course, far away from here, but this is the area where the sun is, and the Earth orbiting around the sun, moving along, and then the moon moving, okay, around, orbiting around the Earth. Okay, and so this is going to show us how the phases of the moon happen. So when the moon is right in front between the Earth and the sun, that is the new moon. Okay, so the part of the moon that is lighted by the sun is far away from us, so on our side it would be all dark. Can we see the new moon? Okay, can we see the new moon? Okay, when I ask a question, it's the time for you to type. Go typing. Not really, not easily. Okay. So any other answers, and why? Why is it not really and not easily? A little? Can we see the moon a little? Okay. What do you think, guys? And why? When the moon is actually a new moon, the light from the sun bounces off away from us. Yes, that would actually explain how in the eclipses we see the moon, okay, but not in the new moon. Okay. It's not because it's behind the Earth. The moon is always there, is really in front of us, okay, and we would actually be, see it. The reason why we don't see the new moon is because of the light of the sun. Okay, that's right. So we cannot see anything, all right, and the new moon we cannot really see it. During the day, can we see the stars? The only time when we can see the new moon is if we have a solar eclipse, okay? And a solar eclipse is exactly when then the shadow of the moon falls onto the Earth. But that doesn't happen very often. And the reason is because the orbits are not aligned. So if this is the plane of the ecliptic, remember that I talk about that, the plane basically that makes the Earth orbiting around the sun, the moon has a declination over that. And so the moon doesn't always, the shadow of the moon most of the time misses the Earth when it's new moon. Sometimes if the orbit of the moon happens to be on the ecliptic, okay, basically what happens is the moon orbits this way. Let me see if this will be shown better here with this program. Okay, no, not Jupiter, I don't want moon. Okay, but let's go a little farther out. Right, okay. All right, so let's see if we can go even a little farther out. Okay. Okay, let's see. So if this is, okay, so if the plane of the ecliptic were here horizontally, can you see that the orbit or the plane of the orbit of the moon is not horizontal? Okay, and so the only time, and if the sun were here, okay, if the sun, let's see where the sun is here, all right, oh, the sun is over here. Is that the sun? No, no, the sun is over here. Okay. This is kind of hard because once we find one, we miss the other. The moon is very small compared to that. Okay. All right. So we cannot see. Okay, there we have the moon. All right. So let's advance a little bit. So here is the situation at this time today, okay? So the moon, the sun is over here, all right? The sun is over that way. The moon is a crescent, no, a waning moon, okay? It's a waning moon because it's going to be going, okay, let's see. No, that's going back. Okay, so this is going forward. All right. So the moon is going to be moving, you know, that way. And when it gets in between, when the orbit of the moon gets in between, exactly in between the sun and the earth, that would be new moon. All right. So you see how it's moving. Now we are on, okay. All right, so about here, that would be new moon, okay? So 11:22, okay, there you would have about the new moon. And so now if we look at, okay, not this way, let's see, if we are going to look at that, okay, see the orbit of one and the other. Oh, I didn't want to do that. I love this program, but sometimes the navigation drives me nuts, I have to tell you. Okay, because it messes me up. Okay, but the interesting thing here is that because the moon is new moon, so we cannot see the moon because the sun, the light of the sun basically doesn't let us see that. The only time when we see the new moon is when the shadow of the moon falls onto the earth. But in this case, okay, I catch it also here. In this case, the shadow of the Earth, of the moon is going to miss the Earth, is going to go above the Earth, okay, and not cause an eclipse. That is okay. Whew. That was a long explanation for for something. Okay, did you have any other other comments on that? All right, so we cannot see the new moon. The same reason why we do not see the stars during the day. All right. Explain it all again. Good luck. That was awesome. All right. So, but it's basically the same thing. As the moon moves in its orbit, when it's 90 degrees between the sun and the earth, then we have a quarter moon. Okay, and then we start seeing a gibbous moon that is kind of a waxing gibbous moon. It's not totally full, but it's not a quarter. Then when the moon is exactly opposite to the sun, then we have the full moon. Whew. And then we have the waning gibbous moon. The last quarter is when they have also 90 degrees, but now on the other side. All right, and then a waning crescent until we go again to the new moon. Notice though that as the moon orbited the Earth, it took 27 and a half days to do this. The Earth moved along in its orbit. Okay, and so the starting point of the moon Earth, now it would be off, not looking directly at the sun, and so there's a little bit more time there. That is what is called the so this is what is called the sidereal or synodical month. Okay, so that is the difference between the sidereal month is this. It would be until the time it takes for the moon to go back to its position. The synodical month is the time it takes for the moon to be new again, to be in the same phase again. Okay, all right. Ooh. Lots of interesting explanations. I love this animation. It is an animation. You see here the dates going by, so it is basically pictures of the moon at different days during the whole month. And the reason why it also the moon kind of gets closer, and farther is, do you remember that when we talk about elliptical orbits? So why does the moon make this bobbing motion, okay, that looks like it's getting closer? It's kind of trippy, yeah. Why is it that it looks like the moon is getting closer at some time in the month? And it's always in the same time, really. Do you remember why? Okay. Any takers? Because of the angle of the Earth axis? No? Okay, yeah, it is. Annika is right. It's because it is closer. Okay, so in this case, remember that the moon moves in an elliptical orbit. Okay, so let's see. No, this one. Okay, so the moon moves in an elliptical orbit, and so it's not totally round. All right. Okay. And so this is not really a circle that you see here. And so because it is not a circle, sometimes the moon is actually closer to the Earth. And so that is why it looks closer, because it is actually closer. Okay, so, simple answer. Because the elliptical orbit of the moon brings it closer to the Earth. Excellent! Yeah, shoo-hoo! The orbits are perfect circles. Excellent. Good. All right. That is what I want, is when you start putting these concepts together, okay, to be able to understand them. Okay. Good deal. So now we go to the eclipses. Whew. So the lunar eclipse, okay. The lunar eclipse happens when the shadow of the Earth falls onto the moon. Okay. The solar eclipse is the other way around. Is when the shadow of the moon falls onto the Earth. The interesting thing is why are orbits different shapes? All orbits are elliptical. Some are closer to circles, the circle being a special case of an elliptical orbit, but they are all elliptical. Okay, and it has to do with the mass of the objects and the speed at which they move. Okay. How often do solar eclipses occur? All right, excellent question. So that is what I want you to find out. All right. That's right, Annika. Yes, because of the different gravities of the different bodies around the object orbiting. Yes. So remember the laws of gravity that Kepler and Newton discovered. Those are the things that govern really the orbits of the planets. And so it is very interesting that through observation, people have been able to figure out, for example, by observing how long it takes for Jupiter to move around the sun, they are able to figure out what is the mass of that object, of Jupiter. The same thing when they look at the moons of Jupiter, and Galileo discovered the moons of Jupiter, he was able to calculate how, he was able to observe with the telescopes how long it took for the moons of Jupiter to go around Jupiter. And so with that, later on, when Newton discovered these formulas, they were able to calculate the mass of the moons of Jupiter. So these things are really very deterministic, so they really follow these formulas. It's really cool, okay? All right, so what's the difference between a lunar eclipse and a solar eclipse? Annika asked the questions, other planets also have eclipses, right? What do you think the answer is? Okay. Yes? Question mark. That is not an answer, Haley. That is a question. Okay. What conditions, okay, I would guess so. Okay. What conditions would make the excellent, Emmeline? All right. Those with moons. All right. Yeah. So all the planets that have moons have also eclipses. Okay. Some are more common, others are more rare, depending on the distance between the moons and the planets and so on, the sizes of that. But yes, all the planets that have moons have eclipses, okay? So they all look different from one to the other, but that is the issue. Okay, so from your question, solar eclipse, the moon's shadow is on the Earth. Lunar eclipse, the Earth's shadow is on the moon. Excellent, Sabrina. That's right. That's right. Okay. That is pretty obvious. Can't believe I missed it. Okay, no. These are all the questions that we need to ask. Okay. Are there planets with very large moons? Yes, yes. So Pluto, that is a dwarf planet, okay, is actually a system of two dwarf planets orbiting around each other, okay? And so they, Pluto and its satellite have eclipses, okay? And so this one is a kind of a rare case, but that is how Pluto is. Yes, there are planets without moons. Which are the planets without moons in our solar system? Which are the planets without moons? Venus doesn't have a moon. Excellent. Which other planet? There's one more. Pluto actually has a moon, like I was explaining. It's a system of actually two. Yes. Mars has two moons, and Mercury is the other one that doesn't have a moon. Okay, yeah. I do not know what is the name of the other dwarf planet or the satellite of Pluto at this time. Okay. So Mercury is the other one that doesn't have a moon. Okay, that's good. It's probably is not so much because it's so close to the sun. It could be probably that is a good reason, because probably a satellite around there in that area, it would have fallen into the sun. It would have, the gravitational pull of the sun would have probably taken it. So the thing about Titan heavy seas is true? Okay, let's find out. That is a good question. That is a good question. It could be that it's too hot for a moon. The main reason is probably that the gravitational pull of the sun would actually have, suck anything around Mercury, okay, and taking it in, So Mercury and Venus, probably that is the reason. So if you can think of that, the two closest planets to the sun are the ones that don't have moons. Okay, the Earth has one, Mars has two, Jupiter has a lot, and Saturn has also a bunch. Okay, so all the rings and everything are basically satellites. All right. So it seems that there is a relationship there between, of course, the mass of the planet and then how close or how far it is from the Earth. Okay. So what makes a partial? Jupiter has 67 moons so far. All right, because it's interesting. When I was your age, and I remember studying this, we were counting about 10 moons for Jupiter. All right. So now they have discovered a whole bunch more. Okay. Yeah, so the sweet spot for life also has the beginning for a sweet spot for moons. How beautiful, really. Isn't it amazing? Okay. And it's interesting because having this moon, okay, makes for a lot of other interesting phenomena. All right, especially the phases of the moon. Pluto has 3 moons: Charon, Hydra, and Nix. So Charon is the largest. So thank you, Sabrina, really. What makes a partial lunar eclipse? What makes a partial lunar eclipse? And what makes a partial solar eclipse? So what would make a partial lunar eclipse? And what would make a partial solar eclipse? That's right. There's only half a shadow. Okay, so the partial lunar eclipse is when the moon passes Okay, it's not perfectly lined up. That's right. So, and it all has to do with the declination here of what I was saying of the orbits. Okay, so when the moon passes through the shadow of the Earth, but the shadow is not completely covering the moon, then you have a partial lunar eclipse. And when you have that the lunar, the solar eclipse is interesting because it depends on where you are on the Earth. So here in this particular case, yes, a partial lunar eclipse happened on the 23rd of October. So just last month, it was a partial lunar eclipse. It was beautiful, really. Okay, but and then on the 23rd, just 2 weeks after that, basically in the next new moon, we had also a solar eclipse. Okay, at the beginning of November, we had a solar eclipse just a couple of weeks ago. So here, depending on where you are on the Earth, you would see a total solar eclipse or a partial solar eclipse. You see that if you are here in this area, right where the whole shadow of the Earth falls onto the Earth, this dark dot there, then you would see a total solar eclipse. But if you are not that lucky and you are here, let's say in Morocco, okay, then you would see a partial solar eclipse because only you would see part of the shadow, the penumbra of the shadow obscuring the sun. Okay, not that much. So Haley, you make a very good point. That is the reason why I want you for the assignment to find out when are the next solar and lunar eclipses. Okay, and write it down in your calendar. So make an appointment, okay, for that. All right. So very, very interesting thing and an idea. So let's write that down and make sure that we don't miss the next ones. Okay. Now remember that we were talking about the phases. Okay, the phases of the moon. All right. I have two questions. For a lunar eclipse to happen, yeah, an appointment with the moon. For a lunar eclipse to happen, what phase has the moon to be in? For a lunar eclipse to happen, what would be the phase of the moon? Remember, these are the phases of the moon. Okay, new, waxing, first quarter, gibbous, full, waning, last quarter, waning, and new moon. Okay. Yes, I know. I need to finish right now. Okay. Thank you, Mac. So, what phases of the moon full? That's right. And for a solar eclipse to happen, what should be the phase of the moon for a solar eclipse to happen? New. Excellent. Let's pray. Good job, guys. I think that you are getting this. All right. Good deal. Okay. Let's see who has a mic that can say the closing prayer. Mac, would you like to? Okay. Hi. All right. Excellent. Amen. Excellent, guys. Thank you. Thank you. If you have any questions, okay, if you want to remain here online and ask the question, you can either ask it on the mic or the webcam or chatting, okay. If you don't have any questions, we'll see you next time. Thank you. Let me see, someone here found this. Okay, I look up the eclipses and different days, so I'm assuming it's to do with your location. Yes, Okay, so at your location, all right? Yes, at your location. So find the eclipse at your location. Okay, so the solar eclipse may not be visible, or the lunar eclipse, depending on where you are at. How do you look at recorded lessons? I have linked all the recorded lessons. Okay, now yeah, they are in YouTube in the Latter Day Learning channel. All right, but I've also linked them in the lessons. So if you go here, let's go to one of the previous lessons that I do have recording. I don't have recording for all the lessons. Sadly, the thing didn't work for everything. Okay, but if you go now to the lesson, okay, you have here the link to the lesson. Okay, so that is the full hour. Okay. So I should put where I'm at, but if it is during this summer, I will be in New Hampshire. So I should look it up. Where will I be? Right, that's right. That is absolutely right, Christina. Annika, yes. Okay. Thank you, Haley. Yes, I was able to put the recordings now there of all the lessons, both for science and geography. They are there. Okay. Oh, let me see this one, this link. Okay, did I click it? Okay, let's see. No, let's see. Okay, there we go, Okay, thank you, Annika. Let's see. Okay, let's take that out. Okay, so let's oh, okay. Also, it's not, is it in China? Oh, there it is, the north part of China. Okay. All right. Okay, so over there, Weihai Park. Okay, so let's see if we go to Google Earth, then it should be along the coast. Oh, sorry. In the Yellow Sea. Okay, right here. Okay. Weihai. Okay, that could be, okay, Peihai, you know. So that would be the place that we're talking about. So it's in the Yellow Sea, right between Korea, the Korean peninsula. Okay, good, excellent. Okay, let's see. Okay, all right, so it's over here. Now, if I look at the other map of the tides, okay, this one here, yes, I see that in this particular area right there in the Yellow Sea is marked to have very high tides, okay, with lots of ranges. You see that there in that part, and that is consistent then with this description here of the diurnal tides over there. Okay, now if I go to the other map of the tides, this one, let's see, where are we? The one where we had the, okay, oh, this one, yeah, this one here, we see, yes, so there in the Yellow Sea, in the area of Peihai, diurnal tides, see? So that matches the diurnal tide patterns that we see there with pay high. Okay, so now we know that that is where we are at. We are talking about there in the Yellow Sea. Excellent. Wow, excellent. That's awesome. Thank you very, very much. Thank you for finding that out, gents. All right. And we'll see you next time. Okay. Thank you. If you have any other questions, let me know. Thanks. Bye-bye.